D3.js is a JavaScript library that uses digital data to drive the creation and control of dynamic and interactive graphical forms which run in web browsers. It is a tool for data visualization in W3C compliant computing, making use of the widely implemented Scalable Vector Graphics, JavaScript, HTML5, and Cascading Style Sheets standards. It is the successor to the earlier Protovis framework. In contrast to many other libraries, D3 allows great control over the final visual result. Its development was noted in 2011, as version 2.0.0 was released in August 2011. Context: the first web browsers appeared in the early 1990s. They were initially capable of displaying static web pages only. The only way for a user to interact with the web was through clicking links and scrolling pages. There were many efforts to overcome such limitations. One of the most significant was the integration of JavaScript as the scripting language for web browsers. JavaScript gradually became the de facto standard language for creating web pages with rich user interactivity. This played a crucial role in the decision to use JavaScript as the language of D3.js. At the same time, researchers, engineers, and practitioners from various branches of engineering and science looked for tools that would enable web browsers to visually present data within web pages. There were multiple projects with that goal, each of which had its successes and failures, and inspired the subsequent ones. The most notable examples were the Prefuse, Flare, and Protovis toolkits, which can all be considered as direct predecessors of D3.js. Prefuse was a visualization toolkit created in 2005 that required usage of Java, and visualizations were rendered within browsers with a Java plugin. Flare was a similar toolkit from 2007 that used ActionScript, and required a Flash plugin for rendering. In 2009, based on the experience of developing and utilizing Prefuse and Flare, Professor Jeff Heer, Ph.D. student Mike Bostock, and MS student Vadim Ogievitsky of Stanford University's Stanford Visualization Group created Protovis, a JavaScript library to generate SVG graphics from data. The library received notable acceptance both by data visualization practitioners and academics. In 2011, the development of Protovis was stopped to focus on a new project, D3.js. Informed by experiences with Protovis, Bostock, along with Heer and Ogievitsky, developed D3.js to provide a more expressive framework that, at the same time, focuses on web standards and provides improved performance. Technical principles: embedded within an HTML web page, the JavaScript D3.js library uses pre-built JavaScript functions to select elements, create SVG objects, style them, or add transitions, dynamic effects or tooltips to them. These objects can also be widely styled using CSS. Large data sets can be easily bound to SVG objects using simple D3 functions to generate rich text graphic charts and diagrams. The data can be in various formats, most commonly JSON, comma-separated values or GeoJSON, but, if required, JavaScript functions can be written to read other data formats. Selections: the central principle of D3 design is to enable the programmer to first use a CSS style selector to select a given set of document object model nodes, then use operators to manipulate them in a similar manner to jQuery. For example, by using D3, one may select all HTML/p elements, and then change their text color, for example to lavender. The selection can be based on tag, class, identifier, attribute, or place in the hierarchy. Once elements are selected, one can apply operations to them. This includes getting and setting attributes, display texts, and styles. Elements may also be added and removed. This process of modifying, creating and removing HTML elements can be made dependent on data, which is the basic concept of D3.js. Transitions: by declaring a transition, values for attributes and styles can be smoothly interpolated over a certain time. The following code will make all HTML/p elements on a page gradually change their text color to pink. The default duration of such transitions is 250 milliseconds. However, this value can be changed in the code. Besides duration, important characteristics of transitions are delay and ease. Data binding. For more advanced uses, loaded data drives the creation of elements. D3 load a given dataset, then, for each element of it, create an SVG object with associated properties and behaviors. Appending nodes using data. Once data is bound, D3.js will follow a pattern utilizing explicit enter command, an implicit update and explicit exit. Using method chaining, anything following the enter command will be called for each data item that isn't represented by a node on the selection, while update is called on all existing nodes and exit is called on all existing nodes that do not have data to bind to them. There are several examples of how this works. API structure. D3.js API contains several hundred functions, and they can be grouped into following logical units: selections, transitions, arrays, math, color, scales, SVG, time, layouts, geography, geometry, behaviors, math, generation of pseudo-random numbers with normal, log normal, Bates, and Irwin-Hall distributions. Transformations in 2D, translation, rotation, skew, and scaling. Arrays. D3 array operations are built to complement existing array support in JavaScript. D3 extends this functionality with functions for finding minimum, maximum, extent, sum, mean, median, and quantile of an array. Functions for ordering, shuffling, permuting, merging, and bisecting arrays. Functions for nesting arrays. Functions for manipulating associative arrays. Support for map and set collections. Geometry, computing convex hull of a set of points. Computing Voronoi tessellation of a set of points. Support for point quad-tree data structure. Support for basic operations on polygons. Color, support for RGB, HSL, HCL, and LAB color representation. Brightening, darkening, and interpolation of colors. Usage. Data visualization company Datamir officially uses D3.js as its core technology, while the New York Times sometimes uses it for rich graphs. It is used by the id editor for editing OpenStreetMap. D3.js has been extensively used for GIS map making, managing both GeoJSON and Topogen files as input. Related tools and libraries. General visualization tools and libraries, Datacopier, SAS, Tableau, R, processing, tools built on top of D3.js, Free Data Map, Company Data Visualization Tool, Dimple.js, Flexible Axis-Based Charting API, Cubism, Time Series Visualization, Rickshaw, Toolkit for creating interactive time series graphs, NVD3, Reusable charts for D3, Crossfilter, Fast multidimensional filtering for coordinated views, DC.js, Dimensional charting JavaScript library, C3.js, D3-based reusable chart library, non-D3 chart libraries, AnyChart, HigCharts.js, Flot, Piety, Timeline.js, ZingChart, Graph Visualization, Sigma.js, Arbor.js, References. Further reading, Background on Data Visualization and Information Graphics, Kirk, Andy, Data Visualization, A Successful Design Process, Birmingham, PACKT Publishing, ISBN A978-1-84969-346-2. Cairo, Alberto, The Functional Art, Berkeley, Peachpit, ISBN A978-0321834737. Background on D3.js itself, Bostock, Michael. Ogievitsky, Vadim. Here, Jeffrey, D3, Data-Driven Documents, IEEE Transactions on Visualization and Computer Graphics, IEEE Presser, using D3.js, Beginner Level, Murray, Scott, Interactive Data Visualization for the Web, An Introduction to Designing with D3, Sebastopol, California, O-Euro-Unregistered Trademark Riley Media, ISBN A978-1-4493-3973-9. Timms, Simon, Social Data Visualization with HTML5 and JavaScript, Birmingham, PACKT Publishing, ISBN A978-1-7821-6654-2. Using D3.js, Intermediate Level, Dewar, Mike, Steele, Julie. Blanket, Meehan, eds. Getting Started with D3, Creating Data-Driven Documents, Sebastopol, California, O-1 trademark Riley Media, ISBN A978-1-4493-2879-5. Kitsu, Nick, Data Visualization with D3.js Cookbook, Birmingham, PACKT Publishing, ISBN A978-1-7821-6216-2. Others, Navarro Castillo, Pablo, Mastering D3.js, Birmingham, PACKT Publishing, PA 352, ISBN A. 9787783286286,270. Teller, Swisk, Data Visualization with D3.js, Birmingham, PACKT Publishing, PA 194, ISBN A9781782160007. Vion, Christophe, Developing a D3.js Edge, Constructing Reusable D3 Components and Charts, Bleeding Edge Press, PA 268, ISBN A9781939902023. Meeks, Elijah, D3.js in Action, Manning Publications, PA 325, ISBN A9781617292118. McLean, Malcolm, D3 Tips and Tricks, Leonpub, PA 580. External links, official website, D3.js Gallery.